Hello my dear students, so how are you all? I hope you all are doing well. I am Bhagunti K. Patel, your dedicated chemistry faculty, committed to guide you and prepare you for your CET examination. So today we will be discussing about our class discussion questions on the chapter Some Basic Concepts of Chemistry. So without any further wait, let us start to solve our questions. So the question number 1 is, the total number of protons in 20 gram of calcium carbonate is. So they have given a calcium carbonate which is nothing but your CaCO3. So in this calcium carbonate, if we take 20 gram, how many number of protons will be there? They are asking. So number of protons is equal to your atomic number. Correct. So now if you calculate by using your atomic number for these all calcium carbonate, so you will get around your 50. So the total mass number of protons will be around 50 for one molecule of calcium carbonate. So now as they have given 20 grams, so how we can calculate? See, in 1 mole, how many number of molecules we will be having? Avogadro's number of molecules, correct? So now 1 mole of calcium carbonate is nothing but your 100 grams. So 100 grams corresponds to Avogadro number of molecules, then 20 grams will correspond to X watt. So it will be your 100 divided by, it will be 20 into Avogadro's number divided by 100, correct? So now directly we can write our number of protons as to be number of moles into, we will write number of moles into number of protons present in one molecule. So that is 50 into, we can write our Avogadro's number, correct? So now how can we calculate number of moles? That is number of moles will be equal to your given mass divided by molecular mass, 20 divided by 100. Next, number of electrons or 50. Next, into, what is your Avogadro's number? 6.023 into 10 raised to 23. So now how you can do? 1s are 5s are 5 1s are 5 10s are. So number of protons comes around 6.023 into 10 raised to 24. So the correct option will be your option number D. Now the next question is, the density of water and ethanol at room temperature is. So you have here water and you have here ethanol. That is your H2O and ethanol is nothing but C2H5OH. At room temperature, they having density 1 gram per milliliter and 0.8 gram per milliliter respectively. So that is for your water density of water, and here this is the density of your ethanol. So now they have asked what volume of ethanol you have to find contains the same number of molecules as present in your 200 ml of water. So now if you take 200 ml of water and X ml of your ethanol, both should contain what same number of molecules. So the one rule which is very important for this is, remember this sentence. So same number of moles will contain same number of molecules. If number of moles is same, then number of molecules will also be same, because number of molecules will be number of moles into Avogadro's number. So what is the conclusion here? We have to take here number of moles of your water must be same as number of moles of your ethanol. So it is nothing but what? Weight of water divided by molecular mass of water is nothing but 16 plus 2, 18 grams. And weight of your ethanol divided by molecular mass of ethanol is nothing but carbon is your 12, 12, 12 2s are 24, 6 plus 16, 12, 16, 1 carry 46. Correct? Now, we do not have weight given here, but instead of weight, we have been given here density. So, what we can do, you already know that density is nothing but what? Weight divided by volume. Correct? So, now, what you can write weight as? Weight as density into volume you can write. Correct? So, the density of water is nothing but you can write here density of water into volume of water divided by 18. So all this substitution you should not do in your examination hall. You should be directly going to this formula, nothing else. Okay? So what you will be doing in examination? Directly come here. So 1, density is 1, volume of water is given 200 divided by 18. Density of ethanol is given as 0.8 and volume of ethanol you have to calculate 46. So from here volume you can calculate 1 into 200 into 46 divided by 0.8 into 18. So in this volume will come around 630 ml it will come. So out of which option is near? So option number B is near 638 ml. Clear? So in examination which thing you will do? So you will see directly everything and you should calculate this in mind. So weight is nothing but density into volume and you will compare the both equations. Okay. Now the next question is the mass of oxygen gas which occupies 11.2 liters at STP would be. So see, this is based upon your molar volume. So molar volume concept says that any gas if you take 1 mole of any gas at STP if you take, so 1 mole of any gas at STP will be equal to having 22.4 liter of volume it will be having. Correct? Now any gas here they have given an oxygen gas. So 1 mole of oxygen gas will occupy 22.4 liter of volume. Now 1 mole of oxygen is nothing but your 32 grams of oxygen will occupy 22.4 liter of volume. Then how many grams of oxygen will occupy 11.2 liters of volume? So it will be around your 11.2 into 32 divided by 22.4. 2 to 16 correct? 16 grams of oxygen will occupy your 11.2 liters of your oxygen at STP. Now the options given here is the gram atomic mass of oxygen which is equal to 32. So it's saying that 32 grams of oxygen will occupy 11.2 liters. No, 32 grams of oxygen will occupy 22.4 liters. 1/4 gram atomic mass of oxygen, that is 32 divided by 4 mass. No, it is wrong. Double the gram atomic mass of oxygen, it says 32 into 2 grams will occupy 11.2 liters. No. Half of the gram atomic mass, that is 32 divided by 2. We already got 32 divided by 2 here. So the correct option will be option number D. So for this question, you no need to write the 16 gram also. So you can get here directly. So see, if I directly calculate here, you can get your X as 11.2 into 32 divided by 22.4 liter. That is 32 divided by 2. Half of the gram atomic mass of your oxygen gas. Clear? Okay. So next question is, in reaction container, 210 gram of hydrogen and 210 gram of chlorine are mixed for the formation of HCl. So we are forming HCl gas from hydrogen gas and chlorine gas. What is the limiting reagent and how much of HCl is formed in the reaction? So here what we are doing? So we are basically taking hydrogen plus chlorine to form HCl. Stoichiometric coefficient must be balanced. And now see here. You can clearly see 1 mole of hydrogen require 1 mole of chlorine and gives 2 moles of HCl. So in grams, let us convert because it will be easier for us as the given option is in grams and also in the options side the production of HCl are given in grams. Clear? So see here, 1 mole of hydrogen gas is nothing but 2 grams. 1 mole of chlorine is nothing but 35.5 into 2, 70. And 2 moles of HCl is nothing but 35.5 into 1 plus 136.5. 2 into 36.5 because 2 moles are there. Now what is the given? Given here is 210 gram, 210 gram. So we have to identify which is the limiting reagent. So carefully observe these two things. So here you can see 70 grams of chlorine require 2 grams of hydrogen. Then 210 gram of chlorine will require how many grams of hydrogen? So X value will be equal to 210 into 2 divided by 70. 3s are, therefore you can get here 6 grams. So 6 grams of hydrogen is only utilized. So 210 grams are available. So there is an excess reagent. So hydrogen will be your excess reagent and chlorine will be your limiting reagent. Correct? So now how many mass of your hydrochloric acid will be obtained? They have asked. So simple. You can do here, that is, see, 2 into 70 grams of chlorine will give you 2 into 36.5 grams of HCl. Then your 210 grams of chlorine will give how much of HCl? So you will have 210 into 2 into 36.5 divided by 70. 71s are, 73s are, and it will come around 219 grams. So the correct option is option number C. So here your chlorine is limiting reagent and HCl is formed is 219 grams. So it is wrong, chlorine is limiting reagent, and the HCl formed will be, let me take 219 grams here. Option number D will be your correct option. So this question, same question you can do in terms of your limiting, POAC concept also. Okay. So that is your principle of atom conservation rule. It will be more easier. Next, how many significant figures are present in 2.0000135? So when you are calculating significant figures in point side, if there is a number which is your natural number will be there. So you have to consider all these 0 also. So how many significant figures are there? 1, 2, 3, 4, 5, 6, 7, 8 significant figures are there. So option number B will be your correct option. Instead, if in the question they have given like this, so then how many significant figures are there? Only 3 significant figures are there. In the question like this, they have given 10035. Then all these 3 are your significant figures. Okay. Now, next question is, which of the following statements about Avogadro's hypothesis is true? So when we are talking about our Avogadro's hypothesis, which of the statements given here will be true, they are asking. So Avogadro's hypothesis, this says that at STP, if you take 2 gases and these 2 gases must be having same volume. If they have same volume, then they will have same number of moles. And if they have same number of moles, then they will have same number of molecules. That we already studied. That equal number of moles of gases will contain equal number of molecules. Correct? So, this is your Avogadro's hypothesis. Now, let us see. Under similar condition of temperature and pressure, same temperature and pressure is there, gases react with each other in simple ratio. So, gases will react at simple ratio. This is about your Gay-Lussac's law of mixing volume. It is an example. So, this is not the correct statement. Next, under similar conditions of temperature and pressures are maintaining constant, equal volumes, the same volumes of all gases contain same number of molecules. This is true because if temperature and pressure and volume is also equal, that is the PV is equal to nRT. Correct? So pressure is same, volume is same, temperature is same. This is a universal gas constant. Then number of moles will also be same. If number of moles same, then number of molecules will also be same. And this is the exact Avogadro's hypothesis. Option C. At NTP, all gases contain same number of molecules. So at standard temperature and pressure if you are taking, and volume we are not varying it. So here the number of molecules will depend upon volume also, because see here again PV is equal to nRT. So then volume is directly proportional to number of moles, and number of moles will vary with your given mass or your molecular mass. So then this statement is not true. Gases always react with gases only at the given temperature and pressure. So it is saying that if you are reacting any gas, if you take any other reactant as solid, it will not react. Gases react with gases only, it is saying, which is completely wrong in our organic or any chemistry, any concept of your chemistry. So this statement is also wrong. Therefore, option number B will be your correct option. Next question is, how many moles of your magnesium phosphate, Mg3PO4 twice, will contain 0.5 moles of oxygen atoms? So we have to calculate moles of your magnesium phosphate. So see here, if I take 1 mole of magnesium phosphate, how many moles of oxygen it is containing? So there are 4 2s are 8. So 8 moles of oxygen it is containing. Now they are asking, if the oxygen content is 0.5 mole, then how many moles of magnesium phosphates we are taking? So what is the value of X now? So X will be simply 0.5 into 1 divided by 8. 0.5 is nothing but 1 divided by 2 into 8, 1 divided by 16, and it is nothing but 0.06. So the correct option will be your option number A. Next question. Assertion it is given, in 0.2 molar aqueous solution of sodium sulfate, Na2SO4, the molarities of sodium ion, Na plus ion, and sulfate ions all in the solution are 0.4 molar and 0.2 molar respectively. So whether your assertion is correct or not, let us see. So if they have given 0.2 molar of aqueous sodium sulfate solution, so 0.2 molar of aqueous sodium sulfate solution, that means water is your solvent here. Whenever this kind of sentence is given, I told you how you have to decipher. You have to take volume as 1 liter. So if volume is 1 liter, how many number of moles? Molarity is equal to number of moles divided by volume in liter. Volume you have taken 1 liter. So here number of moles will be equal to your molarity. So here clearly you can say that 0.2 moles of Na2SO4 in 1 liter of your solution. Correct? So now 0.2 moles of Na2SO4 is there. Clearly understand now. If I take 1 mole of Na2SO4, how many moles of sodium are there here? So 2 moles of sodium are there, and how many moles of sulfate is there? Only 1, right? So 1 mole of sulfate is there. So if there is 1 molar of Na2SO4 solution, then what will be the molarity? It will be 2 molar, it will be 1 molar. Here also we can see the same. If there is 0.2 moles of Na2SO4, then how many moles of your sodium is present? So it will be 2 into 0.2 and here 1 into 0.2. So what will be the molarity? Obviously 0.4 molar, 0.2 molar. Correct? So whether it is given correct? Yes, it is given exactly right. So the reason they have given 1 mole of sodium sulfate gives 2 moles of sodium ions and 1 mole of sulfates ion on dissociation. That is true, and that's why we have multiplied by 2 and 1 for your sodium and sulfate respectively. So here assertion, reason both are correct, and reason is the correct explanation of assertion. So therefore the option A will be your correct option. Next question is 2 oxides of metal. So there are 2 oxides of metal which contains 50% and 60% of oxygen by mass respectively. If the formula of first oxide is MO2, then what is that of your second? So what is given here, carefully observe. So the first oxide is MO2. Let us take second oxide as MXOI. What they have given, percentage oxygen they have given. So let me write here, 60 divided by 16 will give you 3.75 and 40 divided by 32 will give you 1.25. Now you will take the least ratio. So as this is the least value, you will divide by this one only, 1.25, and here also 1.25. So what you will get here, 1 and here 3. So what will be your empirical formula? MO3, and this will be your second oxide. So the correct option will be your option number B here. Okay. Now let us move towards the next question. So 10 gram of magnesium is burnt in closed vessel containing 5 gram of oxygen. So you are burning magnesium with oxygen. Which reactant is limiting reagent and how much of excess reactant will be left, they are asking. So limiting reagent also they are asking and excess reactant also they are asking. So see, what will happen actually when you burn magnesium with oxygen? You will get magnesium oxide, MgO. So now let us balance it. So you will get this equation. So from this clear equation, you can say that 2 moles of magnesium react with 1 mole of oxygen to give 2 moles of magnesium oxide. As the question is given with respect to mass, take it as mass here. So 1 mole of magnesium is 24. So therefore 2 into 24 grams of magnesium will react with your 32 grams of oxygen to give what? Magnesium oxide. So 2 into your 24 plus 32. So that is nothing but your 56. Correct? So now given mass is your 10 and oxygen they have given 5 gram. So clearly listen what you have to do here. So first take these two equations with clarity. Let's see. Your 32 grams of oxygen require how many grams of magnesium? 2 into 24 grams of magnesium. Now 5 grams of oxygen will require how many grams of magnesium, dear students? So X will be nothing but 5 into 2 into 24 divided by 32. Correct? So how much it will come around? So it will come around your 7.5 grams. Correct? 8 3s are, 8 4s are, 32 here, 2 1s are, 2 2s are will be there. So 1 divided by 2 is nothing but 0.5. So 5 into 3 into 0.5 you will take 7.5 grams you will. So 7.5 grams you are getting. So 32 grams of oxygen, complete amount of oxygen, 5 grams of oxygen will react with 7.5 grams of magnesium. So how many grams are remaining here? So remaining will be 10 minus 7.5, that is 2.5 grams are remaining. This is your excess. Now, which reagent is completely utilized? Whole 5 grams are utilized. So therefore it is a limiting reagent. So now the correct option will be your oxygen is limiting reagent. Oxygen is limiting reagent. These both options are wrong. Magnesium is in excess. Yes, magnesium is in excess by how many times? 2.5 grams. Option number A. But option number C, see, oxygen is a limiting reagent and oxygen itself is in excess by 2.5 grams. The sentence is wrong. So you have to carefully observe the sentence also in examination. Now, the next question. Which of these statements given below is incorrect? So out of these statements, which of the statement is incorrect they are asking. So the first statement, 1 gram atom of carbon contains Avogadro's number of atoms. So see here, whenever you are giving 1 gram atom, if in case in examination if they have given 12 gram of carbon, then it is nothing but it is talking about weight only. If they are talking 1 gram atom of carbon, or let's say if they are talking 12 gram atom of carbon, then they are talking about 12 moles of carbon. Understood? So the gram atom defines about your mole. Understood? So now here, carefully get it here. 1 gram atom is nothing but 1 mole of carbon atoms contains Avogadro's number of atoms. That is true. 1 moles of any atom will contain Avogadro's number of atoms. True statement. 1 mole of oxygen gas contains Avogadro's number of molecules. That is also true, because 1 mole of oxygen molecule will be equal to Avogadro's number of molecules itself. 1 mole of hydrogen gas will contain Avogadro's number of atoms. Atoms means hydrogen atom. So the Avogadro's number of atoms will be not there. So 1 mole of hydrogen gas, Avogadro's number of molecules. But in atoms it will be 2 times Avogadro's number of molecules. So this statement is wrong and this is an incorrect statement. 1 mole of electron. If we take 1 mole of electrons, then how many electrons are present? Avogadro's number. So it is Avogadro's number. It is also correct. So therefore option number C will be your wrong option. Next question. The largest number of molecule is in. So they are asking about number of molecules. So how you will get number of molecules? The very simple equation, you already know that number of moles is equal to weight divided by molecular mass given number divided by Avogadro's number. So from here, can you get here given number as a weight divided by molecular mass into Avogadro's number? You have to just calculate for each of the following. So now let us calculate for this one. So 54 gram of water. So 54 gram of water means here weight 54, molecular mass of water is 16 plus 2, 18 into Avogadro's number. So 18 ones are 18, 3s are 54 is that. So that is 3 into Avogadro's times option A. Next option B, let us take 28 grams of carbon monoxide. If you take carbon monoxide, 28 gram they have given. So what is the molecular mass of your carbon monoxide? That is 12 plus 16. So 12 plus 16 will give you 28 into Na. So that is only Na times are there. Option C, 46 gram of ethyl alcohol. So ethyl alcohol, your molecular mass 12 2s are 24, 24 plus 32 plus your 6. So how much it will 22, 24 plus 16 plus your 6. It will be 46 only. So it also have Avogadro's number of molecules. Now option D, 54 grams of nitrogen pentoxide. So that is 54 grams is given. Nitrogen pentoxide molecular formula N2O5. So N2O5 is nothing but 5 into 16 plus 14 into 2. It will give you 108. So it contains half of Avogadro's number. So this is your lowest number of molecule and this is your highest. So which is the correct option? Option number A will be your correct option. Next question. Statement is given, 1 mole of oxygen and nitrogen gas have same volume at same temperature and pressure. So if you take same mole, 1 mole of each, so same moles is given. Next, have same volume, will have same volume at what? If they have same temperature and pressure. So I already told you, your PV is equal to nRT. If N is same, R is same, P is same, volume will also be same. Avogadro's hypothesis. So statement 1 is true. 1 mole of gas at STP occupies 22.4 liter of volume. It is true. 1 mole of any gas if you take, it will occupy 22.4 liters at STP. So both statement 1 and statement 2 are correct. So therefore option number A will be your correct option. Next. So CH4 gas, 2O2 gas give rise to CO2 gas and 2H2O gas. Everything is in gas given. Which of the following statement is incorrect on the basis of above balanced chemical equation? So they have given 4 options. Which option is incorrect we have to identify. So let us take this equation here. CH4 plus 2O2 oxygen gas will give you carbon dioxide plus 2 moles of H2O. Now from this equation, can I write 1 mole of methane will react with 2 moles of oxygen and 1 mole of carbon dioxide and 2 moles of hydrogen? In terms of mass, if I write, can I write methane as 12 plus 4, 16. 16 grams of methane will react with 2 into 32 grams of your oxygen, 64, that is 64 grams, and 1 mole of carbon dioxide, that is your 44 grams of carbon dioxide, and 2 into 18 grams of your water. Correct? 26 gram. Now, this in terms of an STP if I take. So, how many volume it will be take? 1 mole will contain 22.4 liter. 2 moles will contain 2 into 22.4 liter. So, 1 mole 22.4 liter. 2 moles 2 into 22.4, that is your 44.8 liters. 22.4 liters, 44.8 liters. Correct? Now if I talk about number of molecules, so can I write here Avogadro's number of molecules of methane will react with 2 times of Avogadro's number of your oxygen to give 1 moles of Avogadro's number of carbon dioxide and Avogadro's number of 2 into Avogadro numbers of your water. So in all possible terms I have written. Now come to the option here. So it says that 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. It is true. Correct? Option B. 1 mole of CH4 reacts with 2 molecules of oxygen only. No. Here 1 mole of methane will react with 2 into Avogadro's number of oxygen. Not just 2 molecules of oxygen. So it is wrong and therefore it is a correct statement. Next, let us come to here. So 1 mole of methane corresponds to 22.4 liter. 2 moles of oxygen corresponds to 44.8 liter of oxygen. Similarly for your carbon dioxide and water. Now in terms of grams, 16 grams of methane react with 64 grams of oxygen to give 44 grams of carbon dioxide and 36 grams of water. Oh, 36 it is there, no? Sorry, 36. Okay. Now, next question. 123.5 gram of chloride occupies volume of 22.4 liters at STP. The percentage of chlorine in this chloride is 29%. The atomic weight and valency of the element is. So you have an element, let's say Mx and Cly. So Mx and Cly is giving a chloride of your 123.5 grams. 123.5 grams. And this 123.5 grams is occupying how many liters of volume? 24 liters. So therefore it is corresponds to your 1 mole. As 1 mole of MxLy will occupy your 22.4 liters of volume and its mass is 123.5. It is nothing but your molecular mass. Correct? So here it is your molecular mass then. Now let us come the percentage they have given. So chloride percentage is 29 they have given. So here percentage of element is given as 29%. Now come to the valency they have asked, right? So valency corresponds to which of your term in your concentration term it corresponds to your normality. And with respect to normality, we can correspond to your equivalent weight. So if any molecule if you take, so number of milli equivalent of your, carefully listen, milli equivalent of your MxCl will be equal to your milli equivalent of chloride ion. It also equal to milli equivalent of your metal. Okay, which is there present. So now we do not want this. We can take these two equations. Now let us calculate your milli equivalent. So now as MxCl is our whole molecule is of 100%. So let me take 100%. And now if I take your molecular mass of this MxCl(Y), it is 123.5. And what I have to calculate? I have to calculate its valency. Let me calculate valency by X. Now milliequivalent of your chloride. So how you can take? You can take here 29 divided by what is the atomic mass of chlorine? So 35.5. And what is its valency? It is 1. So from this, what you will get your X value? X value will be equal to your 29 divided by 35.5 into 123.5 divided by 100. Correct? So you will get around 1. Valency is 1. So as valency is 1 of this your metal atom, then you can say the molecule is MCl. Now what is the atomic mass of this metal? So atomic mass of this metal must be equal to your atomic mass of metal plus chlorine, that is 35.5. So how much you will get atomic mass of metal here? So that is 123.5 is equal to Y plus 35.5. So Y will be 123.5 minus 35.5. It will come around 88. So valency is 1 and mass is 88. So therefore option number D is your correct option. Now let us move towards the next question. What is the total number of electrons present in 0.16 gram of methane? So how many number of electrons are there? They are asking. Correct. So now if I take methane here, methane is nothing but what? CH4. How many electrons are present in one molecule of methane? So here it will be 6 plus 4, that is 10 electrons in one molecule. Correct. Now let us come. How many molecules are present in 1 mole of methane? That is 16 grams of methane will contain Avogadro's number of molecules, and how many electrons it will present? 10 into Avogadro's number of electrons it will be having, as one molecule is having 10 electrons. Then any molecules will be having 10 into Avogadro's number of electrons. Now 0.16 gram of methane will be having how many electrons they have asked. So what will be the value of X here? So X will be nothing but 0.16 into 10 into Avogadro's number divided by 16. So if I multiply by 100 here on both sides, so here it will get like this. Correct? 10 ones are 10 tens are. So you will get 6.023 into 10 raised to 23 divided by 10. It will give you 22. So the correct option will be your option number D. Next question. The following statements demonstrate the law of multiple proportion. So out of these statements, which statement is giving an explanation for your law of multiple proportion or an example for your law of multiple proportion? So when you talk about law of multiple proportion, it says that if you take any two element, let's say your X and let's take your hydrogen and oxygen. So hydrogen and oxygen can combine in some particular ratio to give two other compounds, different compounds, like water it can give and hydrogen peroxide it can give. Similarly, carbon dioxide and carbon monoxide. So this is about your law of multiple proportion. So it is talking in particularly about your two elements combination. Remember? Okay. If you remember this, then the next sentence it says that if you consider one mass as a constant, if your hydrogen peroxide and water is there, let us take hydrogen as a constant mass. Then if you take the ratio of mass of oxygen in water divided by mass of oxygen in your hydrogen peroxide, it will be an same ratio or it will be a simple multiple of each other. That is what your law of multiple proportion says. Now come to an options here. So an element forms two oxides. So there is an element, it forms two oxides, XO and XO2, containing 50 and 60% of oxygen respectively. The ratio of masses of oxygen which combines in 1 gram of element is 1:2. So clearly you can see here, it is talking about the ratio of mass of oxygen by making X element's mass as constant, that is 1 gram. That is true according to your statement. And you are comparing two element compounds. Here X and O oxygen you are taking and you have made two different compounds. So it is correct of your multiple proportion, but we have to check the values also. Later we will check, because in this particular question no need to correct the options also. Now see, hydrogen sulfide H2S contains 5.89% of hydrogen. Water contains 11.1% of hydrogen, and sulfur dioxide contains 50% of oxygen. So clearly see, so here they are talking about your hydrogen sulfide, water and sulfur dioxide. Together it contains what type of element? Hydrogen, oxygen and sulfur. So is this a reciprocal proportion? Yes, if you compare three different elements, out of which two elements combine in proper ratio and giving a third element, a third compound, that is a reciprocal proportion. So it is a wrong option. Next is your 3.47 gram of barium chloride. 3.47 grams will combine with 2.6 gram of Na2SO4 to give barium sulfate and sodium chloride. Correct? How many grams here? 3.88 and 1.95. So if you clearly see, this is a reaction and they have given here mass. Now if you take this mass and you add it, so it will give the same value. So it is your law of mass, conservation of mass it is. Conservation of mass, but we are talking about your multiple proportion. This is also wrong. Then 20 ml of ammonia gives 10 volume of nitrogen, 30 volumes of hydrogen at constant pressure and temperature. At constant pressure and temperature, volumes of gases combines at particular ratio they have given. Correct? So it is your Gay-Lussac's law of combining volume. This is also a wrong statement. So correct statement was obviously option number A. But let us see this ratio is correct or not. So now see here, what you have been given? You have been given XO and XO2 here. Correct? So now they have given also you the percentage of your oxygen present, 50 and 60 percentage. Correct? So if you calculate percentage of oxygen, 50 and 60. So what will be a percentage of metal will be there here? 50 and here will be 40. Now let me take this particular equation and let me calculate for your X value. So here it is X percentage of oxygen. Percentage of oxygen is 50. You can calculate 16 mass and total mass will be your X plus 16 into 100. This will give you 1 divided by 2, 16 plus X plus 16. So you will get 2X plus 32 is equal to 16. So what will be your value of X here? Sorry. So you will get here 32 as 2X, 32 as X plus 16. So what is the value of X? 16 grams. So X element has a 16 grams here. Okay. So now what we can do here is we have to compare the mass ratio. Correct? So here XO and XO2 is there. If I take this one is mass as 16 and what is the mass of oxygen? 16. Mass of X is 16. Mass of oxygen will be 32. We have to take X mass has to be constant. So what we will do? We will divide by 16 only to get 1. So what you will get? 16 divided by 16 is to 16 divided by 16. 16 divided by 16 is to 32 divided by 16. So 1 is to 1 and 1 is to 2. So what is the ratio of oxygen now here? So it is 1 is to 2 ratio, which was given here. Is it true? Correct? So no need to do in examination, but just for your information I have told you. Now, the number of atoms in 0.5585 kg of iron is. So atomic weight of iron is given. Very simple answer. So atomic mass of iron is nothing but 1 mole of iron. Right? So 1 mole of iron will contain any number of atoms. Correct? So 1 mole of iron is 55.85 grams. Will contain any number of atoms. Then 0.5585 kg. 0.5585 into 10 raised to 3 grams will contain how many grams? So here x will be nothing but your 0.5585 into 10 raised to 3 into Na divided by 55.85. So how much you will get? So here you will get x has to be 10 into Avogadro's number. Correct? You will get 10 into Avogadro's number. Now the option given here is little bit twisted. See. So the twice that in 60 gram of carbon. So if you take 1 gram of carbon has to be 12 grams. 12 grams of carbon will have any number of atoms. Now 60 grams of carbon is nothing but your 2 into 5 into 12 grams of carbon atom here. 5 into any number of atoms, correct? So it is saying that twice that of 60 grams of carbon. So twice that of 60 grams of carbon is nothing but 2 into 5 into 12, which will be equal to 5 into 2 into Na, which is nothing but 10. So which is equal to your option obtained here, 10 into Avogadro's number. So option number A is correct. So option number B is saying that Avogadro's number divided by 10, which is wrong. Half that in your 8 grams of helium. So if you talk about 8 helium, 2 grams of helium will have Avogadro's number. Correct? So now, how many 8 grams of helium will have how many atoms here? So 8 grams of helium will obviously have here 8 divided by 2 number of Avogadro's number of atom, 4. 4 Avogadro's number. So half of this is saying it means, so that is 2 Avogadro's number it is talking about. Next is 558.5 into 6 into 23 into 10 raised to 23, which is also wrong. You cannot multiply directly by your mass given. Next question. A solution containing Na2CO3 sodium carbonate and NaOH sodium hydroxide requires 60 ml of 0.1 normal HCl using phenolphthalein as an indicator. Methyl orange is then added to the above titrated solution when a further 50 ml of 0.2 normal HCl is required. The amount of NaOH present in the original solution is. So now see, in the solution what you are having? You are having a Na2CO3. Let me make you understand this one. Okay, so you are neutralizing with your what? HCl, correct? So now the HCl which you have taken is 0.1 normal. Okay, now remember here, when you are using phenolphthalein as an indicator, phenolphthalein will indicate your value as it will convert itself into your pink color at what? Half of your sodium carbonate is used. So under phenolphthalein, what will be the neutralization? Phenolphthalein, half of carbonate will be left. Okay. Now, to this particular solution, what I did? I have added methyl orange. So, methyl orange when I added, what it did? It neutralizes this half sodium carbonate. So, here there will be complete neutralization after this. Neutralization is occurring. Now carefully listen. So during this phenolphthalein reagent, what normality of HCl I have used? 0.1 normal HCl I have used and 600 ml of HCl I have used. For this half moles of your sodium carbonate, how many normality of concentration of HCl I have used? 0.2 normal HCl I have used and 50 ml HCl of this I have used. Correct? Now, this is the extra amount of HCl required for complete neutralization. Now, suppose if I ask you, if this normality of your HCl is 0.1 normal only, how many extra volume of HCl you have to add here for your complete neutralization? So, you will take this formula. That is N1 V1 of 0.1 normal, N2 V2 of 0.2 normal. So which volume you have to identify? Volume of your 0.1 normal, correct? So it will be 0.1 into volume into 0.2 into how much volume it required? 50. So we'll get volume as to be 0.2 divided by 0.1, 100. So for complete neutralization, initially you should have added how much? Instead of 600 ml, you should have added 700 ml of HCl. If you have added 700 ml of HCl of 0.1 normal, it would have given you complete neutralization. Correct? Now, complete neutralization has happened from your 700 ml. Now tell me, how much ml of HCl is required to neutralize this NaOH? Remember, here we required how much? We required 100 ml HCl for your half Na2CO3. So then for full Na2CO3, how much I required? So you will require here another 100 into 2. Correct? So therefore 200 ml you will require for this one. So how many left here? So therefore 700 minus 200 will give you 500 ml. Required for what? NaOH. Understood? So what we got here in conclusion, when you take Na2C43 and NaOH together, how much required it is? 700 ml of 0.1 normal HCl is required for your complete neutralization, out of which Na2SO3 required 200 ml and rest is required for your NaOH. Now can I apply your normality, your formula law of equivalence? Yes. So N1 V1 for your NaOH will be equal to N1 V1 of your HCl. So what will be the value here? So NaOH normality, I can take it as your weight, which I have to calculate, divided by, so how much of your value of your molecular mass? 40 divided by its acidity is 1, as only replaceable 1 OH minus ion is there. Into volume is 1000, 1 liter we will talk. Correct? Now, HCl normality is 0.1, volume we have used 500. So what you will get? Weight you will get 0.1 into 500 into 40 divided by 1000. So 0, 0, 0, 0 cancel. 5 4s are 20, 20 into 0.1 will give you 2 grams. So how many weight of your sodium was present initially? So sodium was your 2 grams. If they have asked weight of your sodium carbonate, how you would have done? So for sodium carbonate, if they have asked, you can do like this. N1 V1 of sodium carbonate, N1 V1 of HCl. So here you will take N1 of sodium carbonate and then V1 to be 1000 and volume it will be 0.1 into 200. Instead of 500, you will take here 200 volume. That's all. Understood? Okay. So the next question is equal masses of hydrogen, helium, oxygen. So all have mass of your hydrogen, is equal to mass of your helium is equal to mass of your oxygen they have given. What you have taken? In a container in identical condition, the ratio of gaseous volume on. So what you have done? You have taken the identical pressure and temperature condition. So they have asked what will be its gaseous volume. So you know that gaseous volume is directly proportional to number of moles. Correct? So as number of moles it is directly proportional, you can say directly proportional to weight divided by molecular mass. As weight is same for everything, so you can take a volume is inversely proportional to its molecular mass. Now if I take the ratio of this one, can I write the ratio as a 1 divided by molar mass of hydrogen, 1 divided by molar mass of helium, 1 divided by molar mass of oxygen? How much it will be? 1 divided by 2 is 2, 1 divided by 2 is to 1 divided by 4 is to 1 divided by 32. Now multiply by 32. You will get 1 here. 4 divided by 32, 8. 32 divided by 2, 16. So the ratio is 16 is to 8 is to 1. So option number C is your correct option. So I hope you have understood all the solutions. So all the best. Thank you.